Hi everyone, welcome back to my YouTube channel. I am Reeti and I'm back with another lecture in the DBMS series. So in the last couple of lectures we learned about serializability, types of serializability, view and conflict and much more. In this particular video we would be learning about concurrency control mechanism. So without any further ado, let's get started. So before starting with concurrency control mechanism, let's learn about concurrency control. So what is concurrency control? It is a process of managing multiple user access and modification in data simultaneously in shared or multi-user database system. Now consider an example of IRCTC. Now in this IRCTC, at a given time, there are multiple users who are going ahead and booking ticket from themselves. Now here, since there are multiple users who are going ahead and booking ticket from themselves, we can call it a multi-user system. Now here, this IRCTC database would be getting updated or modified by multiple users. So we can say that this particular database is a multi-user database or a shared database. So for managing this multiple users and multi-user database, IRCTC uses this concurrency control. So it uses the concurrency control so that it can manage multiple user access and modification in data simultaneously in a multi-user database system. Now how it helps? So the first one is data consistency. So it ensures that the data remains accurate and reliable despite concurrent access. So concurrency control makes sure data is consistent even if there are multiple users who are accessing the website or the database at the same time. Now coming to the second thing, that is isolation. So it maintains the isolation property of transaction so that the outcome of a transaction is not affected by other concurrently executing transaction. Now since there are multiple users who are doing transaction at the same time, so consider user 1 is doing transaction T1, user 2 is doing transaction T2 and user 3 is doing transaction T3. Now as part of this transaction we are doing some operations of read and write. As part of this transaction also we are doing some read write operation. As part of this transaction also we are doing some read write operation. So there should be a isolation which should be maintained between different transactions so that if there is any modification of data which is being made here, this particular transaction doesn't affect from this particular read and write operations which is happening in transaction T1. So there should be an isolation between these three transactions so that the operation of one transaction doesn't affect the operation of other transaction until or unless this particular transaction is committed. Now coming to the third pointer, that is serializability. So it ensures that the result of concurrent transaction is same as if the transaction has been executed serially. So in the concurrent schedule, or you can say in the concurrent transaction, there is a non-serial execution of transactions. So because of this non-serial execution, there is some consistency issues which arises in our database. So serializability makes sure that this particular non-serial execution is converted into a serial execution so that consistency issue is encountered so that our database follows the ACID properties. Now coming to concurrency control mechanism. So we had serializability, using which we were telling that if a given schedule is serializable or not, and there were view serializability, conflict serializability which were helping us for the same. Then what was the need of this concurrency control mechanism? So as part of serializability we were only telling that if a given schedule is serializable or not, but as part of concurrency control mechanism we use some techniques to make that particular schedule as a serializable schedule. So here we are using techniques to make a schedule as serializable. Here we were only using techniques to tell if a given schedule is serializable or not. So concurrency control mechanism are techniques used in database management system to ensure that the transactions are executed concurrently without leading to any inconsistency in the database. So whenever there is a concurrent execution, or you can say non-serial execution, there are some consistency issues which arises in our databases. So concurrency control mechanism makes sure that this particular inconsistency is not happening in our databases. Now in serializability we check if a given schedule is serializable or not, but in concurrency control we use certain techniques to make a schedule serializable. So we use certain techniques to make this particular schedule as a serializable schedule. Now why this particular concurrency control mechanism is needed? So there are certain anomalies or there are certain conflicts which arises in our databases. So first is lost updates. So whenever two or more transactions update the same data simultaneously and one of the update might be lost. For example, if two users modify the same record at the same time, the changes made by one user could override the changes made by other. So consider that if there are two transactions T1 and T2, T1 is performing a write operation on A and T2 is again performing a write operation on A. T2 commits. So here the updated value of A is considered 10. Here the updated value of A is considered 60. So here the value of A is committed at 60. But after this the T1 also commits. So final value of A updated in our database would be 10. So you can see that there are some inconsistency which is arising, and the changes made by one user could be override by the changes made by other user. Now coming to the second, that is dirty reads. So whenever a transaction reads data that has been modified by another transaction but not yet committed, if the first transaction rollbacks, the other transaction will read invalid data. So consider if there are two transactions T1 and T2. As part of T1 I am doing a read of A and write of A. As part of T2 I am reading the updated value of A. So here I have read the updated value of A. So consider the value of A here was 10. After update the value of A was 20. So here the value of A which was read was 20. Now consider at some moment this particular transaction T1 fails. So it will go ahead and roll back all the values. It will go ahead and roll back the value of A to 10. But here the value of A was read as 20. Now this particular value becomes invalid. So that is why dirty reads happen. Now coming to the third one, that is uncommitted dependency, or you can say dirty writes. So when a transaction modifies data that has been read by another transaction, leading to inconsistency if one of the transaction rollbacks. It says that consider if there are three transactions T1, T2 and T3. As part of T1 I am doing an update on A. As part of T2 also I am doing an update on A. And as part of T3 I am doing a write on A. And consider that because of any reasons this particular transaction fails. So since this particular transaction has failed, it will roll back the value of A to its original value, but here we haven't read the value of A. So this particular transaction has done some modification in A, and after this modification has been done, this particular transaction is reading this value. Now this particular value is inconsistent because there has been a failure in T1. So because of the failure in T1, this particular value becomes invalid, and because of that this particular value always become invalid. So there is uncommitted dependency because the transaction haven't committed, and because of the transaction haven't committed, there are some inconsistency which arises in our database. Now coming to inconsistent retrievals, that is non-repeatable reads. So it happens when a transaction reads the same data multiple times and get different value each time because another transaction is modifying the data between the reads. So consider if there are two transactions T1 and T2. As part of T1 I am reading the value of A. As part of T2 I am modifying the value of A. And again as part of T1 I am reading the value of A. So the value of A which is read here and the value of A which is read here would be different. So here you can see that as part of only one transaction, if I am doing two read operations, I am getting modified data. So that leads to non-repeatable reads. Now coming to phantom reads. So it occurs when a transaction reads a set of rows that satisfy a condition, but another transaction inserts or deletes rows that affect the set before the first transaction complete. This results in first transaction reading different set of rows if it re-executes the query. Consider if there are two queries Q1 and Q2. As part of Q2 I am adding or inserting some rows in my DB. As part of Q2 I am reading the number of rows or fetching the number of rows. So if I do this Q2 operation once, I get 3 rows, and if this Q1 operation is also executed at the same time, it will go ahead and add one more row, and after consider 1 second only, if I am again doing this read operation, I'll get 4 rows. So you can see that there are different number of rows which I am getting because of the addition. If consider that this is not addition, this is deletion, and it goes ahead and deletes some of the rows. So first it was 3 rows, now it is 2 rows. So here you can see that there is some discrepancies in the number of rows which I am reading while doing the query. Now coming to the some common concurrency control mechanism. So the first one is log-based protocol. Now as part of this we would be learning about two-phase locking, strict two-phase locking and locking protocols. Coming to the next one, that is timestamp based protocols. So as part of this we would be learning about basic timestamp ordering and Thomas Wright's rule. The third one is optimistic concurrency control, that is OCC. Fourth one is multi-version concurrency control, that is MVCC. Now from semester and interview point of view, this log based and timestamp based protocols are important, so we would be learning about them in more depth. About optimistic and multi-version, we would be seeing about the definition and what they are exactly, but we won't be going in more depth. So this was all about concurrency control mechanism, why it is needed and what are the different techniques of concurrency control mechanism. In next set of videos, we would be starting with the different techniques. So this was all about this video. I hope you like this video. So if you like this video, please hit the like button. If you're someone who is new to my channel, can go ahead and watch out the tech content first. And if you find it useful, can go ahead and subscribe. Also, if you have not followed me on my social media handles, you can go ahead and follow. The links are in the description. Till then, take care, keep learning, keep growing, keep smiling. Bye all.